For a particular clothing store, the claim is that the mean purchase price for all purchases is $40. The store manager feels that the average purchase price is bigger than $40. A random sample of 20 purchases gives a sample mean of $45.26 and a sample standard deviation of $20.67. Let alpha equal 0.10. Our first step will be to find the level of significance. The level of significance is always equal to your alpha level, so your answer will be 0.10. The next step is to state your null and alternate hypotheses. Will it be a left-tailed, right-tailed, or two-tailed test? When stating hypotheses, your first row will always be your null, and that is always written as H sub 0 colon mu equals, and then you determine the value. In this case, the paragraph says the claim is that the mean purchase price for all purchases is $40, so our mu is equal to 40. For our alternate hypothesis, it is always written as H sub 1 colon mu. You decide if it's going to be less than, greater than, or not equal to, and it will be the same number as your null hypothesis. In our paragraph, it says the store manager feels that the average purchase price is bigger than $40. So we believe that the average, or mu, is greater than 40. Now we want to determine if it is a left-tailed, right-tailed, or two-tailed test. In this case, it'll be right-tailed. A trick to remember this is taking your inequality. We'll do this one in a different color. So if we have less than, greater than, or not equal to, if we take these inequalities and make them into arrows, the less than is pointing to the left, so it'll be a left-tailed test. When the inequality is greater than, if you make it into an arrow, it is pointing to the right, so it'll be a right-tailed test. For a two-tailed test, there are two lines going straight across, and that's how I remember it as two-tailed. For our next problem, we'll use a sampling distribution and then explain why. In this case, we will use a t-distribution. And this is since the population standard deviation is unknown. Now that we know we're using a t-distribution, we can then go into part D, where it is finding the sample test statistic. The equation to find t is t equals x bar minus mu divided by S, or our standard deviation, that quantity divided by the square root of n. So we will take our information from the paragraph above and fill in for what we have. X bar is 45.26 minus mu, which is 40, divided by our standard deviation, which is 20.67, divided by the square root of n, which is 20. When we do this out, t is equal to 1.14.